Hi, so let's start with the next chapter, that is C language in our journey in embedded language. So I hope RAM and flash part is somewhat clear. So I will be explaining today the instruction set and covering classes, qualifiers and union structures and enums in under this C language part. Okay. So for flash and RAM, if you have any doubt, please leave your comment. Okay, and one more thing, how to proceed towards learning embedded system. So as I tell, like every time try to think from that perspective. When you see a TV remote, just try to think how a TV remote works, how the signal goes, so what is inside a TV remote. So this will help you eventually think more. So in embedded, it more about knowing how the system works and then working on it. Okay, so let's look into instruction sets. Okay, so what is instruction set? To be clear that let's read the definition. There are predefined set of instructions which the processor will execute. Like ADC, what is ADC? ADC is analog to digital converter. Similarly, DAC is digital to analog converter. Then addition, like that, multiplication will be there, subtraction will be there, floating point calculation. So these are the set of instruction. It's like when you write in the software a plus b, then the processor knows what it has to do. So this is an instruction to the processor. Then your multiplication, the processor knows what it has to do when it encounters this multiplication sign. So where these are like a in set of instruction that are fed to the processor already, and it is predefined. So main thing is the instruction set cannot be added, means it cannot be updated in the CPU, and it depends upon the manufacturer. So instruction set are predefined set from the manufacturer's end what the CPU will support. So I hope it is clear. So let's move to the next topic, that is in C language. Okay, so before going into the C language, let's first understand how the functions are executed in an embedded system. Okay, so here you can see that I have written a small function. There are two functions, function 1 and function 2, which are called from the main function. So how these are executed, we'll understand. So what happens whenever you are writing a code in an embedded system, first the main function will be executed. The execution will always start from the main. So this is representing a stack pointer or a calling stack. So just understand this. Whenever the execution start, first the main will enter the stack pointer, and here the execution will start. Whatever thing enters into this calling stack will start executing. So main will start executing. So then the stack pointer says, okay, there is another function. So function one will enter into the execution phase. So it will go into here, the execution will start in this section. There will be 10 will be printed on the console. After that, the function ends when it reaches at this location. The function 1 will be thrown outside the stack, or it will be pushed out, popped out from the stack. Then again the pointer will go here, it will check, okay, function 2 is there. Then function 2 will enter into the stack. After function 2 is executed, that it will be printing b, that is value is 2. Then when it reaches again this location, the function 2 will be popped out. Similarly, when it reaches the return value 0, at that end the main function execution also ends and it will be popped out, and finally the stack will again become empty. This will be empty, and your execution stops. We can say execution end. So the execution starts with a empty stack pointer or a calling stack and ends with a empty calling stack. So every time it will start by main function will enter, then the subsequent function which are called will be entered. Suppose you are calling the function 1 from function 2, then it will be like this. Function 1 will enter, after that in the stack there will be main, then function 1, and then function 2 will enter. So it's like whatever function is still executing will be present in the calling stack. Like main is continuously executing till it reaches the return value. So main will be in the calling stack. I hope it is clear. Let's move to the next thing. Okay, so now let's look into the storage classes. So first thing, storage classes describes the feature of a variable like the scope, visibility, and lifetime. So if you declare a variable like int a equals to 10, so it where it is declared, how long this will be available in the program, these are called the scope, visibility, and lifetime. So first in the list is auto. So just remember where auto variables are stored, it is stored in the stack. It initial value is garbage value. So if you just declare int a, so a will be assigned with a garbage value until you assign a default value to it. Then writing scope where till where we can utilize a, so a is available within the block. So if you are declaring a in a c, let's say a dot c file, so inside this int a, if you are declaring, so a is available inside this block. So if you are declaring a inside a function, so a is only available within the scope of this function. So that is the scope. And what is the lifespan? The lifespan is till the end of the block, till this c file is executing or till the function. So let's see how it works. So I am using an online compiler to show you the how auto variable works. So if I just declare a function void fun1, and I declare int a equals to 10, a plus plus, printf percentage d. Okay, so this is a simple function. Let's assign it a value 0. Okay, here if I just call this function, say I am calling this function here. Okay, and moving this, so see it prints 1 even if I call the function two times. Okay, so every time we are calling, it is returning the same value 1 1. So what is happening? So a is a auto type variable, it's a auto type variable. So whenever we call an auto type variable, it will be reinitialized again and again. So a is created whenever it enters the a is created here. So a will be created with the initial value 0, and then it will be incremented to a plus 1, that is equals to 1. Similarly, A will be again created and A will be destroyed here. A will be destroyed here. Okay. And A will again be created with the initial value 0, and it will be again incremented, and that will be equal to 1, and A will again be destroyed. So this is what happens for an auto type of variable. I hope it is clear. So next, let's look into the next thing. So next thing is extern. So what is an extern? We say whenever we want to use a variable in different in multiple code sheets. So let me just put into this perspective. If there is a variable in main.c file and we want to utilize in some, let's say, test.c file. So suppose there is a variable x in the main.c file and we want to use get the value, what is the value of x in the test.c file, then we can use the same variable using the keyword extern. So here also you can read these are global variables. So first thing, these are global variable which can be declared and initialized elsewhere but can be used in any C file using the extern keyword. So the important thing is the extern keyword. So first thing, this will be declared in the data segment, RO data, and in RAM, and then the initial value will always be 0. Unlike the unlike the auto, it will always be initialized with 0 if you don't declare any initial value. So the scope is multiple files and global, as it can be used in any files. So its scope is multiple file and it is global, and it will be available till the end of the program. So if you are extending a variable, so the compiler doesn't know till where it is extended, so this variable will become a global variable and it will be present till the end of the program. So let's see how this works. Okay, so let's declare one file, test.c. Here I want to use an external variable. Let me just write int count equals to 0, and I just want to check how many times this function is called. Count plus plus, and I will just extend, make this variable extended by putting here exter and extern keyword. And you don't want to initialize any variable that you are declaring as extern in the file. So, and here I just write void check count printf percentage d count. Okay, and here I need to have this one, and just include the function here. Okay, so now let's call this check count function, run it. Okay, here just give. So the count is 2. So this function is called twice here. So if I call this function one more time, so the count becomes 3. So this is the value of an extern keyword. So the variable is declared in main.c file, but I am using the variable in other file, that is in test.c file, using this extern keyword. So I hope extern is clear. Okay, now let's look into the next thing, that is static. So what does static means? First thing, let's read. The variable has the property to preserve itself. It will be declared only once and will not be destroyed. Static should not be used inside a structure. So first thing is that it will be declared only once and it will not be destroyed till the end of the program. So let's understand it. So what happens is, when, as I told you, whenever the file is, whenever a variable is declared, when the scope ends, it will be destroyed and it will be reinitialized, right? So first thing, static variable are declared in the data segment of the storage. It is initialized with the initial value 0. It is within the block. The scope of the variable is within the block. It cannot be used in another file. It is only available within the same file or within the same function where it is declared, and its life is till the end of the program. As you say, it will not be destroyed, so it will be available till the program is executing. Okay, let's see what is the static variable then. So as you have seen here, so every time I run the code, the a gets reinitialized with the value 0. So let's make this one as static. And now let's run it. Now see the effect. 1, 2, 3. I have just put the keyword as static. So now what is happening? First, a is initialized to 0. A has increased, but it will not be destroyed. So here a is created. Now a will not be reinitialized to 0. It will only be incremented, and now a will become 2. Similarly here also, it will not be created, it will be incremented and it will become 3. Finally here, after this return statement, when the entire function calling ends, then only this a variable get destroyed, because there is no existence of the function itself or the entire code itself. So I hope this you understand this. So static variable will always preserve its value. It will be created only once. So when I say static, so this becomes a static, and it will always be present till the end of the program. So now let's look into the next, that is registers. So registers are basically, it's a it's a tightly linked memory space with the CPU. So it is, registers are present in the CPU segment. It is initialized with a garbage value. Its scope is within the block and its life is till the end of the block. So there is no use case I could show you for registers, but I can say that when you are checking a communication, let's say you are doing an SPI communication, there you have DR and SR. So what is DR? DR is data register, and SR is your status register. So what happened is the CPU is tightly linked with these registers. So this will be a 16-bit address where the data will be coming, and the CPU can easily read and write the data into that. Okay, so that's the importance of the register. This is very fast in operation than any memory address or variable, and CPU will be executing on them very fast. Okay, so let's move to the next thing, that is qualifiers. Okay, let's understand what are qualifiers. So we understood that storage class is there to define where the variable will be declared, and till how long this variable will be available in the code, and what is the scope, right? Now qualifier gives additional properties to the variable. It gives additional properties to the variable. So if I say a variable is constant irrespective of its location, this variable will be constant, means after declaring the value of the variable cannot be changed. So if I say const int a equals to 5, so you cannot say a equals to 3. No, this will give an compilation error because the a variable is already a constant. Okay, let's see how this looks. Okay, so let's declare a variable as int a equals to 5 and percentage d comma a. Okay, run it. So it gives, okay, okay, printf. So it gives the value output as 5. Okay, now I want to make the value as a equals to 6. So what happens? It prints 6. So now if I put const and try to compile it, so it gives an error saying it's a read only variable. Okay, so constant variable are always read only variables, and you cannot modify the constant variable. Okay, now these constant variable will be declared at a particular position in the memory space. So this will be declared in the flash area, in the flash. Constant variables will be declared and initialize the value in the flash area. Remember this. Now next thing is volatile. So what does volatile means? Volatile means the CPU will not optimize the variable. If you declare a variable as volatile, you say, let's say volatile int a equals to 6. That means every time there is an operation involving a, the CPU will go and check what is the value of a at a particular address. So when you say int a equals to 6, that means a is having some address, let's say 0 cross 002. At that address the value is 6, and you have an operation like c equals to a plus b, or let's say c equals to a plus plus, and you have declared a as a volatile. So every time whenever there is an operation, that time the CPU will go and check, okay, what is the value of a in current location, and do. So CPU will not create a cache for that variable. It will not optimize the variable. Okay, that's the main thing behind the volatile. So CPU optimization for that variable will be stopped. CPU will not maintain any cache for that variable. It will assume that variable may change by any external factors. That's what we define as a volatile, and we stop the CPU optimization. So there is no such examples which I can show. If you define a volatile variable, it will be working like this. For let's look into the next thing, that is restrict. So what does restrict mean? Like volatile, you are saying not to optimize the variable. In restrict, you are saying the CPU to optimize the variable. So this is a qualifier that is used to indicate that a pointer is the only way to access the memory location. The CPU enables, this enables the CPU optimization. So what happens? So if there is a variable, let's say int a, and I declare it 5. Now I say that restrict int star p equals to ampersand of a. By this restrict keyword, I am telling the CPU that this variable a can only be modified using a pointer. So if I say star p plus plus, now again I say star p plus plus, and at this moment you can say that the value of a will be 7, here it will be 6, and here it will be 7. But in between if it get modified to, let's say, a plus plus plus, if I say, so this will be ignored by the cpu, because you are by default saying a can only be changed using this pointer. So that is what the cpu will optimize out any operation directly happening on a. So let's look into atomic. So what does it says? This is a qualifier, ensures that the operation on shared variable are not interrupted by any other threads, mainly used when threads are present. So this atomic variable comes from the RTOs concept. So there can be a thing like you have two parallel process where from two parallel things you want to update a single variable a. So at that time a can be utilized in this process also and can be utilized in this process. So that is the point, like how to make sure that the a will not be affected. Like if I say a is plus plus in this value and a is minus minus here, so finally what will be the value of a? For that, this variable should be declared with an atomic qualifier, so that if one process is executing, then it will ignore the changes on the variable made by another process. So these are the concept in RTOS. When I will be teaching RTOS, then I will be explaining. So just remember, from the interview perspective, there are four types of qualifier: constant, volatile, restrict, and atomic. And just remember the definition, what it is. Okay. Okay, now let's understand what is the memory. So why you are seeing this is because whenever you compile a code, actually the code will be compiled and the different parts of the program will be placed into these different segments. So suppose you write a program, so then the entire program that will be converted into .o file, or after compilation the output file will be considered as the entire text file, and the entire program will be placed into this dot text area of the flash. Then RO data, all the constant variables, all the constant that you are declaring will be placed in this RO data segment of the flash. Now this data segment is very important. So let's say you define a variable int a. So here you are not declaring what is the initial value of a. At that time a will be sitting directly into the RAM section and with a garbage value. So a can have a garbage value. But the moment you declare int b equals to 10, at that time b is having an initial value. So this will be a part of dot data. Why it will be a part of dot data? Because what is the initial value of a that has to be assigned is 10. So initial value will be stored here, b equals to 10, and during runtime b can be updated by the program. So b will, so a copy of b will be also created in the RAM. So b will be there in present in the RAM, and maybe during operation it can become 12 or any. So anything that is having an initial value, like int a equals to 10, b equals to 10, anything that is having an initial value will be placed in data. The initial values will be stored in the flash area and the working value will be updated in the RAM. And anything without any initial value, like int a or float d, everything that doesn't have any initial value, there is no initial value and it will start with a garbage value, that will be stored in the bss section, that is in the RAM section of the memory. Okay, so I hope this is clear. Okay, let's start with structures. Okay, so first thing, structures are user defined data type. Why they are called data types? Because after defining the structure you can also declare a variable of this structure type, like struct data equals to d1. So this d1 will become the variable of type this structured data type, that's why it is called a data type. Second thing, every individual element in the structure will have its own memory, there is no memory sharing. And second thing, if there is a structure, if there is a pointer inside a structure, then copying one structure way, like if I have d1 and let's say I have d2, Then if I say d2 equals to d1 and they have a pointer in them, then that pointer copy will be a shallow copy. So just remember this. This is also important from interview perspective, that copying of a pointer from structure to structure is a shallow copy. So let's look into the coding part. So here I have defined a structure. So this is a structure with three elements in it: one integer, one array integer, and one pointer. So and I have declared two variable of this structure type. I have declared one integer. Now let's first check the size of the structure, how it is. So first thing, the size of the structure should contain the entire size of all the elements. So this is 4 bytes. Then this should be around 2 8 bytes, and this should be 4 bytes. Okay, so 4 plus 4, 8 plus 4, 16. I hope the structure size should be around 16 bytes. So let's run it. The size is 24. So why it is more than, why 8 byte is extra, that I will explain. Okay, so this comes under this structure padding concept. Okay, so first let's look into the structure concept. So from this it is clear that every individual element will be having the every individual element will be having its own memory allocated to it. Okay, so the next thing is, let's update all the values of one structure and then try to copy that structure into another one. Like I have updated the value of all d1 and I have copied d1 into d2. So let's print it. Now one interesting result you can see. So I have updated d1, a as 2, 22, 3, and c as 100. This c is just, I am giving the value as a, like whatever it c is a pointer, integer pointer. In that integer pointer I am giving the address of a, that is the address of this integer. So if I copy d1 to d2, and after copying, if I update the value of d2 dot c, I am not changing the value of d1, still the value of d1 is getting updated, that d1 c is now 100. See, now if I don't change the value of this one and run it, then it remains same. So indirectly what is happening, although we copy d1 to d2, d1 to d2, but still the d1 dot c, this one d1 d2 dot c is pointing towards the same address and the same location as d1 dot c is pointing to. Okay, so that is called the shallow copy. The pointers will be pointing to the same memory location, new memory location will not be created. Okay, now let's look into another aspect. Okay, now let's understand structure padding. So as you have seen that previously the size should be 16, but it was shown 24, right? 8 bytes are more. So let's understand what is structure padding then. So first thing is that structure padding means some extra unused space will be allocated, which will be padded. That will be unused, but it is said as padded. Okay, so now let's understand from code perspective. Okay, now let's understand what does structure padding mean. Here I have given one structure and then just I am printing the size of that structure. So from here I could say the size is 1 byte. These all is 1 byte, up to here it will be 4 bytes. Considering let's say 1 byte, then this is also 1 byte. This is also 1 byte, and these are 2 bytes. This is 2 byte, and finally this is 4 bytes. So if I run it, so it should give me 12 bytes, correct? There is 4 4 8 4 12 bytes, this is fine. But now if I just remove one of the element and run it, still it gives 12 bytes. Why it gives 12 byte, if even if I remove this entire element from here? This gives 12 byte because of the structure padding. So let's understand what's actually happening. So what is happening is, whenever suppose we are having character a and character b, character c, character d, then uint 16 e, uint 16f, and int g. So finally what is happening is one byte is allocated to character A, then B, then C, then D. That is fine. Now next E will be allocated 2 bytes, and then F will be allocated 2 bytes, and then G will be allocated the next byte. Now whenever I am removing the F from this entire location, it will never happen that G will start from this location. This will be, these 2 bytes will be padded in order to maintain this structure. This is called structure padding, and this is very important in case of embedded, because structure padding has one major disadvantage, that it wastes memory. So whenever we are designing our structure, we should design the structure in such a way that we optimize the total amount of elements that are there. So that is called structure padding. Okay. Okay, now let's understand unions. So what are unions? Union are also user defined data type. Why data type? Same. After declaring a union, we can declare a variable of the union. So it's a user defined data type. Here, the difference from structure is that the union will be having the size that is equivalent to the size of the largest element. So it will have 4 bytes. So how union will be defined? So there will be 4 bytes. So this is A, this is B, C and D, and finally the entire thing is allocated to E. So both, all of them will be sharing the same memory location. So now let's look into the code perspective. Okay, here I have declared one union and I have declared a value. Let's see the address, let's see the size of the union. So the size of the union is 4. So this one is 4, this one is 1, this is also 1, this is also 1, and this is also 1. So union will be allocated the size of the largest element, that is 4. Now one more thing which we can see is, okay, so I am updating A, but I want to read the value of G. So I know that the value of the ASCII value of A is ASCII value of A is 65. Let's see what is the value of G printed. See, the value of G is 65. Now similarly, if I change it to B, then it will increase. And the vice versa is also there. If you increase the value of G, then the value of A will change, B will change, C and D will also change. So you can try this on your own. Okay. Okay, let's start with enum. So what are enums? Enums are basically used to increase readability of code. This is the work of enum. So what happens that instead of giving the integer values to the functions, integer values, we are giving name to the integer value. So the modes can also be defined as 0, 1 and 2. Instead of that, we are defining start, stop and end. All of them are also integer. And similarly for week, we can start Monday with 0, but instead of remembering 0, 1, 2, we can just say, we can just define Monday as equivalent to 0, Tuesday equivalent to 1, like that. Okay. So now let's see the example of enum. Okay, so here I have written an enum, and I have created a variable as for this enum week. So as you can see, let's see the size of this variable which I have created, and what all values are there in inside Monday, Tuesday and Wednesday. Let's see. So you can see the size of an enum is equivalent to the size of an integer, because it will hold ultimately, this enum is containing the values, these values. So these values are, what are values? What is the value of Tuesday? This is 1. What is the value of Saturday? This is 5. So where enum will be used? So suppose if you just want to compare, if D1 equals to Monday, then like that I will go to office, like that. Some function you are writing. So in that scenario, it is easy to compare D1 with Monday rather than comparing with 0, because you may need to keep in mind that 0 is equivalent to the Monday. In that way it is simple and it increases the readability. So I hope this is clear. Okay, so today we have covered instruction set, storage classes, qualifiers, structure unions, and enum. So if you have any doubts in these three, you can put it in the comments. I will try to clear it. And in the next upcoming video, I will be dealing with functions and pointers. Okay. And also for the structure unions, you can also follow the video that is coming into the top descriptions so that it will help you in the interview also. Thank you.